All right, so we're going to be working on problem number 2. So let's start a new part here. And we're going to change our units to inches. There you go, in inches. Now this is going to be a revolve problem, which we can see two hints is first we're given a cross-sectional area, and then also, this our part is a round part, so we can be made with the revolve. So let's do that. I'll start a new sketch, say on my front plane. And I'll zoom in here a little bit so we can see better. So what I want to sketch is this cross-sectional area here. So let me start a line. I'm going to say my origin is right at this point. So this first vertical line that I'm making will be this one here. So I need to find out, or it tells me here, my diameter is 4 units. So from this point to here would be my radius. So that's going to be 2 units. This line should be 2 units. So that puts me at this point right here. Now I have to find out the distance given. So the way I find that out is it gives me my diameter for this overall distance. So I'll divide that by 2 and then subtract 4 over 2 from it. Will give me this distance here. So let's do that. 4.28 divided by 2 minus 4 divided by 2, which is just 2. So this distance here is 0.14. So I'll make a line that's vertical, and this distance should be 0.14. All right, now I have to find this depth here because we're at this point. And that, let's see if it's given to us anywhere. So we're given this depth. So if I look over to my other view, it has additional dimensions, which actually has the one that I'm looking for. So my next horizontal line should be 0.8 units long or wide. And then that puts us at this point. Now we need to get a height for this. So the way I'll do that is the same way I found this height. I will divide this by 2, divide this by 2, and then find the difference. So we'll do 4.65 divided by 2 minus 4.28 divided by 2 gives us 1.85 divided by 2. I'm sorry, 0.185. So this height should be 0.185. Its thickness can be found here. So the line over horizontally will be 0.125. This next line should be the same distance as this one, 0.185, 0.185. For this, so now we're at this point, we need to draw this line here, which is that distance is given to us on this other view. So this line should be 0.5, 0.5. You could enter 0.5 into SolidWorks or just simply 0.5. It understands what you're trying to say. This next line will be at the same height. So I can make a line here. If I don't remember what number it was, I would have mentioned it was, I can draw a reference line over. And then right there on vertical and also at the same height given here. This thickness is given to us to be 0.2. So let's make a line. This is 0.2. That puts us at this point. Now we need to find this little distance because there is a minor step there. I'm not sure it's given to us, but what is given to us is this overall height from here to be 4.55. So we'll do the same thing. We'll take half of the total height, 4.65, and subtract half of this, 4.55. So 4.65 over 2 minus 4.55 over 2 gets us 0.05. So this vertical line should be 0.0, how many zeros? 0.05. Very small line, but it's there. And now we move over. We're at this point. We need to be at this point. So I'm not sure that distance is given to us directly, but we can do some math here to find this distance here, which is the same one here. So if we know this total is 1.75 minus 0.55 minus this 0.2, we get our remaining distance. 1.575 minus 0.5 minus 0.2 gives us our remaining distance of 0.875. Maybe what I should do is I'll start doing the math on the SolidWorks. That way, instead of just hearing the numbers, because I'm doing it on a physical calculator that I have. But I'll start, if I can do the math here, I'll do it here. That way you guys can see the actual math that's going on. So I'm doing 1.575 minus the 0.5 minus the 0.2. And that should give me my remaining height. So that's my remaining length, which is correct. Checks out with the number I have on my calculator. So now we're at this corner. Let's move down this height. We can do, again, very similar math. Let's do, I'm gonna try to do that math on SolidWorks. So let's see if it lets me. So I want to do 4.55 divided by 2, and I will be using parentheses in this case to keep everything correct, minus 4.35 divided by 2, and it does it. Nice. Okay, so I'll be doing the math on the SolidWorks from now on. Let's make this line, this horizontal line, which is the depth here. It's given to us to be 0.375. 0.375. I need to find this height. I think it would be best. Let's see, can I get this overall? Am I given this? Okay, it might be best for me to do this right angle and then come back and cut out this 35-degree angle from it. I think that's the approach I'll take. So this vertical line from this point, which we're at right now, to this point, the distance for that would be given. Again, I'll do the math on here. It was just 4.35. Yes, that is 4.35. So overall height is 4.35. Divide that by 2. And then I will be subtracting this 2.8 divided by 2. Let me quickly double check that on my calculator. Just checking the math. All right, so I have this, I'm at this point now. Let's see if we can't get a distance. So we could get a distance from here to this point by taking this 0.68 and subtracting this from it. So we're going to make a line in this direction, the horizontal direction, that is 0.68 minus 0.375, 0.375, not 57. Um, that would take me to this point here. All right. So now I'm here. Now I can make my 35-degree angled line. So from this point, I don't know the distance yet, so I'll just make it a little bit past where I need to be. And then I can change my angle to be 35 degrees. And then after I can trim these pieces. So I can trim these two. So now all I'm left with is this cross-sectional area. So let's continue from this point. We need to find this depth. Let's see if we're given any information over. We were given this, given this. Till this is center. We have the distance from this edge to this center. And then I believe we can use the details given in, yeah, we could to find this point. So just start by making my line, then I can do some math. Okay. So while I'm making these videos, I do occasionally like to pause the video, sometimes to gather my thoughts on my next approach, on my next step. So if there's any cuts in the video or pauses or any jumps, that's why. So I've looked at this for a little bit. The way I could find this length is I have this 1.3125. I can subtract 0.68 from it, so that would give me my length from this point to the middle here of this these circles, these holes. And then if I check out my detail here, it gives me the overall gap to be 0.17. So from the middle to this edge is going to be half of this. So the math that I will do is 1.3125 is my total length. I will subtract that 0.68, which again gives me the distance from this point to this point, the middle. And then I will subtract half of this 0.17, giving me this distance. So I will subtract 0.17. It's a good idea to use your parentheses to keep your order of operations right. 0.17 divided by 2. 0.5475 is the number it spits out for this length. Now looking at my detail, we're right here. We want to, again, cut out this part of it. So when we rotate or revolve it, we're left with this inner groove. That's what's going on here. These revolutions, the revolution of these two parts will leave this groove and then this chamfered here. So let's start a line. We'll go up. The distance is given to us to be 0.1. So much easier when the distance is already given to you instead of having to do math. Let's see, from here, we know the width of this is 0.17. And then I'll come back down to 0.1. And then I could go over to the left in a horizontal line, 0.06. So now we're at this point here. So if you look at our drawing, it's from that point up. Um, Oops, I moved this around. Let me get normal to my. So if you're working on a sketch and you accidentally, let's say, turn this around at a different angle and you want to draw based on a perpendicular view, what you do is you right click on the sketch and this little blue or this black arrow coming out of this blue face, that's going to set us normal to the view that we clicked on. In other words, we're going to be perpendicular to it. So normal to puts you perpendicular. So that's a good tool to know. Instead of doing the math for this line here, since I'm almost done, what I could do is again pick it up from this point, which is here. And then since I'm given this number, this depth is 1.05, 0.05. And then all I have to do is connect these two lines, which should be vertical to each other. However, they are not. As you can see, if I lock onto that point, let me see, are all my lines vertical? It appears that I have made a mistake somewhere along these lines. I will just double check all of these lines to make sure they're vertical and horizontal, which should be the case given by these constraints that are on them. Obviously, except for this line here, which is not. Um, let's try this again. So 1.05. And let's draw this up. So yeah, something is definitely off. Let's see. Okay. Give me a second here. I'm going to take a look at this drawing to see where I messed up. Okay, so I've done a lot of work. I've checked all of these numbers over again. All my lines are either vertical, horizontal, obviously minus this one. All the numbers, all the math we're doing is correct. The error that I found is that in the source, for this part, this number, this thickness in the actual part is 0.165. The rounding that they did to 0.17 means that these dimensions, the width is off just by a tad bit. So the way I'm going to approach that, I'm going to make my line from here upwards to intersect where this point stops, and then I'll make this line. So because of that rounding error in the dimensions that they gave, I'll leave everything else as is. The only difference that we will have will be in this depth here. Their dimension is 1.05. Our dimension for that is 1.045. So we're point, let's do a little bit of math. 0425. We are 0.0075 of an inch off. But again, that's given due to their rounding that they did of these numbers here. So that's at no fault to us. If you would not have had the original document, that you wouldn't have been able to find that out. So I will leave this as this is. Again, we're off just by a slight bit here, but that's as a result of their rounding error on the drawing that they made. So this is our sketch that we want to have, this cross-sectional area here. And the last thing we need to do is create a line of revolution. So I want to revolve this around the center. So hold on, what is this? Don't need that. Let's make, and it could be any kind of line. I like to use a center line, just so it's um a different kind of line than you're given here, so you guys can see that this isn't an actual line that we're using for our drawing, rather just a reference to revolve around. So let's do revolve, and thankfully it automatically selected the line for our line of revolution. We do know we're going 360 degrees, and it selected the right shape for us. So this is, let's see if we can get a, this is pretty much what the part is. The only thing we're missing is our holes now. Let's see, the view we have is this one here. So let's make our holes. Let's see if we have any planes that we could work with. My top plane possibly, or my front plane. Looks like it splits my drawing down the middle. And again, that's a result of whenever I make these drawings, I like to use my origin as some sort of reference. That way, these original planes that we do have, our front, top, and right, would sometimes line up either directly splitting the part down the middle in some way or another. If you guys have been making drawings, your first sketch, on whatever plane, but off into the, but not using the origin as a reference, just off in space somewhere, um, it would be more work for you afterward, because then your original three planes are not gonna line up with your part. So I like to use these as little references. Um, so let's make a sketch. Let's try our front plane. I want to make one of these holes. So let's do those one at a time. Let me do a sketch on my front plane. Okay. Let's do this hole or circle. So let's do a circle. Let's see, what radius would that be? If its diameter is 0.125, its radius, divide that by 2. And this should be 0 in the y direction because we're on the x-axis. Let me find the distance from this center to this point. So if this is our origin and the x-axis, we need to move 2.5 minus point minus this. So let me see if I can do the math here. 2.5 minus 1.3125. That puts me at this, which I believe should be lined up with the center or the midpoint. It's very close. Again, it's off because of the rounding error that was there. But this is fine. Either dimension this by doing the math, or alternatively, what I'll do is I will use the center of this shape, since that's the groove that we're cutting is on the inside of that. So let me see if I can get a dimension for that. From this point, not right away. Let me make a reference line for this midpoint, just so I have a point to, could have also used the point function or feature. I would like to get a number here. This is fine. I just want to view this so it can be changed. Let me make sure to see if there's any rounding going on. There was. So just to line these up, line up these holes with the center of this part. This value I will change to match the one given. It's an extra one, 1.175. Gonna shift that over a tiny bit. So now this is lined up in the middle of this groove here. Let me make ourselves normal to that once more. So let's cut this out just one time, one hole. We'll cut this out in either direction, doesn't matter. Um, Up to next. Is that gonna work? Possibly. Let's find out. It's gonna cut it clean through, which it does. So now we got one hole. Um, that's fine. To make the rest of them, we'll use this feature here. So not linear pattern, but if you drop it down, circular pattern. The direction that we want to go in would be the circular direction around this path. So either select this face here or even the interface of this. I'll just select this one since it's already more accessible. I want to do this equally spaced. Tells me I have 16 items that are equally spaced. And then can I get a preview just to see what it would look like? So that's your preview. You have 16 holes equally spaced out that follow that path, that direction. I believe that is it. So now you have that set of holes there. And then let's do the same thing for this second set of holes. So let's do another sketch again on my front view or my front plane. Let me, we'll put a point here. So that was a point. That function is found right here. I want a dimension. I just want to check out the dimension from here to this edge. Actually, no, that's the wrong point. The point should be 0.53. So what I'm looking for is the middle of this chamfer. So let me make myself normal to the sketch again. So what I will do is I'll drop a point in space and then I'll dimension that point to be 0.53 units from this edge, which should give me the center of these holes. And now I can make a hole. This hole should be, are they the same? They might be the same dimension. They kind of look like it. Yes, I believe they're the same. So again, 0.125 over 2, give you that. If we want to make this one, again, the center of this hole is in the x axis. This y should be 0, putting it on the x axis. And then the height or the x direction for this hole would be whatever dimension is given from the origin to this point. Yes, that's fine. I just want to view this. What number is this? I understand I can't change it. Is there any rounding? No. So 1.97. So this x should be 1.97. That would put me at the center of my chamfer, which is what I want. So I delete these guys. They're no longer needed, just for reference. Let's cut out this hole the same way we did the first time with an extrude cut. And up to next, that works fine. So now we have that cut made there. I think it would have been possible to add those holes on the same sketch. However, I don't know if you would have been able to have revolved this cut. I think it's better to make them separately since the circular pattern that we'll be using for the first one was a total of 16, and this one is going to be a total of 13. So I think making them separate, I mean, not total of 13, total of 32. Either way, it's a different number, so I think making them separate is the best move. So I've made one. Now let's do the same thing that we did previously with our circular pattern. The direction again could be any round direction. Believe you can select this face or the chamfer face. Don't think it would matter. equally spaced once more, but this time a total of 32. And the features that we want to or pattern are going to be, it's going to be this one. So this cut, let me get a preview. So it is showing me a preview. Let me just reselect my face there because it for some reason turned it to an axis. But now that I've selected that face, I can see my preview of my cuts to be made. 32 of them, again, equally spaced. Hopefully that works out. And it looks like it did. So as you can see, we have the holes that are made on the outside, and also these like, since they are made on in a chamfer, they're like ellipsed holes if you stare at them from a certain angle. But I believe that would be it. Let me just double check to make sure there's no additional details, any chamfers. No, that appears to be it. So let me rotate this to match what we have on this on the drawing. Oops. Maybe from this angle. Yep, there it is. So that is part number or problem number 2.